Hello everyone, welcome to the video solution for past paper. This is Edexcel IAL Physics Unit 1 January 2019. Basically this is part 2 of this paper and I will try to complete this paper in the same video. So let's start. Question number 13. A golfer hits a golf ball so that it lands at a distance of 250 meters from the golfer. The golf ball is given an initial velocity u at an angle of 40 degree to the horizontal. Explain why t is equal to 250 over u cos 40 is a correct expression for the time of flight of the golf ball. Assume the ground is horizontal and that there are no wind or air resistance forces. Okay, so we need to prove that this is the expression for the time of flight. This is time of flight. We need to drive this equation and we are given horizontal distance and the angle with initial velocity u. So because horizontal distance is given and air resistance is ignored, so we know that in the case of projectile, horizontal motion is uniform, so we can use S is equal to ut. But in this formula, u is just not a velocity, but it is horizontal component of the velocity. So you can substitute the value. S is the horizontal distance. So if you see the diagram, this is some ball or golfer hitting the ball and it is moving like a projectile. So this is horizontal distance S and time taken t for this whole distance, and of course the total distance S is 250 meter. So I can substitute S as 250 is equal to u. U is horizontal, initial horizontal velocity. In this case this is u cos of 40 into t, and if you make t as a subject of this equation, so t would be equal to 250 divided by u cos of 40. This is the required equation for the time of flight, you can see. Part B, calculate the initial velocity u of the golf ball. So in this case, what we are going to do, we need to find u. So if you recall the situation of a projectile, you know that when projectile moves up, so we divide the whole motion into horizontal and vertical motion separately. So what we are going to do, first I'm going to consider vertical motion separately, and I know that the vertical velocity at the maximum height is 0. So vertical velocity is 0 at this maximum height, and the time taken for the ball or golf ball to reach at maximum heights, I'm assuming it is t1. So I can rewrite the equation for this first half of the motion, and I'm going to use v is equal to u plus at. But for vertical motion, this is vertical velocity after time t, or in this case vertical velocity at that point, which is 0, and u is again is not initial velocity, this is initial vertical velocity, and for this given condition this initial vertical velocity is u sine 40 minus 9.81, because I'm going to take acceleration as minus 9.81, and t is the time to reach at maximum height. This is t1. So I can rearrange this equation as t1 is equal to u sine 40 divided by 9.81. So this is the expression for the time to reach the golf ball at maximum height. What if I say what is the total time to reach at the other end? So total time is double of that time. That means, so you can see that the total time t, which is equal to twice of the t1. This is just for your understanding. I am writing this expression. You can write directly. So t is equal to 2u sine 40 divided by 9.81. And moreover, we have already derived equation for the total time in previous part. So t is equal to 250 over u cos of 40. So we can compare this equation 1, if you say, and the equation number 2. So you can say that 250 divided by 4 cos of 40 equals twice of u sine of 40 divided by 9.81. And now if you look at this equation, the only unknown in this equation is u. So you can multiply, you can cross multiply this equation. You can make u as a subject. If you do this, if you rearrange for this as equation for u, so you can have u square is equal to 250 times 9.81 divided by 2 sine 40 into cos 40. And you can use your calculator to figure out this number, and after taking a square root, so u would be equal to 49.9 meter second inverse, or you can round it off, u is equal to around 50 meter second inverse. This is initial velocity of the projectile. Question number 14. A stationary exercise bicycle has the display shown. Okay, so this is the display, resistance, force, watts, time, speed, and distance. The equivalent motion of the bicycle is displayed as a speed and the distance traveled. One of the quantities being displayed is expressed as watts. State the name of this quantity. So definitely watts is the unit of power. So the quantity associated with this unit is power. So answer is power. That means this is showing the power. Part B, the bicycle provide a resistance force against the cyclist. The unit of this resistance force is Newton. The unit of speed is kilometer per hour. Show that the value displayed for the resistance force and the speed are consistent with the value displayed as watt. That means you need to use the value on the display. You need to find the power, figure out the power from the given values, and see if this power is consistent with the given value of the power on the display. So because on the display we are given force and we are given a speed, so we know that formula for power is work done per unit time, but in this case this formula is not suitable. Instead we are going to use power as force multiplied by V. F into V is another formula for power. So the resistance force is 16 equal to 16 times V, and V is the speed, which is 28. But remember, this is just not 28 meter per second, because they are saying that the speed is in kilometer per hour. So this is not in SI units, so we need to convert this speed as in meter per second. And how do we do that? When we multiply by 1000 and divided by 3600, and if you simplify this whole equation, so power will be equal to 124.44 or 124.4 watt. That's how we can say that yes, the given display of force and the speed is consistent with the power shown on the display. C. The time on the display is given in minutes and the distance on the display is given in kilometer. Deduce whether the speed given on the display is instantaneous or an average. So the idea is we are going to find the speed from the display, and we are going to compare the speed that we are about to find with the speed shown on the display. So the idea of the speed is we need to find V. So average is distance covered divided by time taken. So if you see this, the distance covered is 6.843 divided by time, because formula for average velocity, remember formula for average velocity VAV is distance covered or traveled divided by time taken. So distance is 6.843 divided by time, and time is given in minute as they are saying. So I converted this distance in kilometer. So if you say that, let me just check. Yeah, 6.83 is this distance in kilometer and time in minute. So again, average velocity, distance in kilometer, 6.843, but time is in minute. So T is 13 minutes and divided by 60, because I need to convert this into hour, and it will give you 0.22 hour. So 0.22, and if you find this number, so average velocity or average speed will be equal to 31.5 kilometer per hour. And clearly the calculated average speed 31.5 is greater than 28 kilometer per hour shown on the display. That means the display speed is instantaneous. Question number 15. A student uses a friction-free trolley and a ramp to investigate motion. The mass of the trolley is 0.1 kg. This is the mass. The student releases the trolley from rest, so it moves down the ramp and then continues along a horizontal surface. The velocity time graph of the motion of the trolley is shown. So okay, so this is the velocity of VT graph. Show that the acceleration of the trolley on the ramp is about 4 meters per second. We are given VT graph. Clearly till this point we have accelerated motion, and after that we have uniform motion. So we need to find acceleration. That means from 0 to that point we are going to find the gradient of this line. So gradient of this line is basically acceleration, or acceleration is equal to gradient. So acceleration is gradient of the graph, and if you see the coordinate of this point will be equal to 2.2 of 4, so 2.4, 0.54, 0.54 comma 2.4. So gradient will be equal to y2 minus y1, so 2.4 minus 0 divided by 0.54 minus 0. So acceleration would be equal to 4.44 meter second minus 2. This is the acceleration, which is about 4 meter second minus 2. Part B, calculate the angle of the ramp to the horizontal. So remember, this is the question about inclined plane. A particle is moving along the inclined plane, making some angle theta with the ground, and if this particle is sliding down, and if this is a frictionless, see, they are saying that friction free trolley and a ramp, that means when a particle is sliding down a ramp, frictionless ramp, then the acceleration in this particle is A is equal to G sine theta. That's how we find the acceleration. And in the part B, they are saying find the angles. We have found the acceleration. We can use this relation to find the angle. So you can say that A is 4.44 is equal to 9.81 times of sine of theta, and from here you can calculate theta. So theta would be equal to 26.9 or 27 degree. That's the angle of the ramp. Part C, calculate the time it takes for the trolley to move a distance of 0.74 meter. So in this question, the idea is we have a ramp, and after the ramp, the car or the trolley keeps moving horizontally like this. And the graph which is shown in previous diagram like this. So the first part in which the velocity is increasing is the part where the particle is sliding down, and after coming down from the slope, it is moving horizontally with a constant velocity. So this motion is showing the constant motion. So what I'm going to do, I'm going to find first the distance when the trolley is moving on the ramp. That means I'm going to find length of the ramp or distance traveled on the ramp, and this distance clearly will be the area under the graph, this region. So this region will give you length of the ramp. So this is a triangle, so I can find the D1, which is the length of the trolley, length of the ramp. D1 would be equal to area of the triangle, which is equal to half of 0.54 times height, which is 2.4. So if you simplify this, so D1 would be equal to 0.648 meter. So this is the distance traveled when the car is moving on the ramp, or length of the ramp. And we need to find the time for the total distance of 0.74. So if we subtract this the length of the trolley with the unknown or with the required distance, so we can have the distance D would be equal to extra distance, or you can say the extra distance. So 0.74 minus 0.648, and this distance, which is some distance from end of the ramp to the horizontal. So this is the D, and this D you can find additional distance is a difference of these two, which is equal to 0.03 this distance 0.092. Yes, 0.092 meter. And then I'm going to find the time for that extra distance, because this is uniform motion. So T is equal to 0.092 divided by time, V is 2.4. So this T is equal to 0.038 second. Now if you see the whole situation, what is going on? I found the time for the extra distance after the ramp when the car is moving on the horizontal surface or horizontal ground with a constant velocity. So this is the time for that distance, and we already know the time taken for the ramp, which is 0.54. So 0.54 plus 0.038 is the total time for that distance. That means the total time T is equal to 0.54 plus 0.038, which is equal to 0.578 second. This is the time taken by the car to cover the distance 0.74 meter. Okay, part D. At t equal to 0.7 second, the trolley moves on to a piece of horizontal sponge. The trolley comes to rest after moving through a further 0.25 meter. Calculate the average horizontal force exerted by the sponge on the trolley. So we need to find the average force. That means the idea of finding average force in case of a moving object, generally idea is F is equal to ma. So mass is given, which is 0. I guess 1 kg, 0.1 kilogram, but we don't have acceleration. We found acceleration in the previous parts, but this acceleration was when the particle was when the trolley was moving on the ramp. So we need to find after that distance. This is the sponge region, and in this region we have different acceleration. In fact, that will be deceleration. So distance is given when it is moving on the sponge, so we can use one of the equation of motion, v square is equal to u square plus 2as. So v is 0 because car or the trolley is coming to rest. So 0 is equal to u is a velocity, and it was moving with the constant velocity of 2.4 before coming on a sponge. So 2.4 squared and plus 2a into distance, and distance is 0.25 meter, and you solve this equation for a. So acceleration would be equal to minus 11.52 meter second minus 2. Now you have accelerations, you have mass, so you can figure out force. So F is equal to ma, and if you substitute acceleration here, so F is equal to 1.15 Newton. This is the average resistive force. You can give answer with negative sign if you wish, because if you use minus 11.5, so force will be negative, so it will be accepted because this is opposing force. So minus 1.15, or in terms of magnitude, it is just 1.15 Newton is your answer for the average force. Explain how the acceleration of the trolley down the ramp could be determined experimentally using ICT. So whenever they talk about ICT, that means you need to talk about something related with the computer, like measurement done by the computer using some sensors or motion sensors or light gate, these kinds of stuff. So you can say that you can use two light gates. It's up to you what kind of technique you are using. So you can say that you are going to use a light gate at the end of the ramp. So here you will place at the end of the ramp a light gate. When the trolley pass through the light gate, you can use the timer attached with the light gate and calculate the time automatically, and the length of the length of the ramp and the time. You can find the velocity and the acceleration. It's all about the using light gate and the timer in your experiment. So that's how you can write your answer. Question number 16. A human knee contains a tendon which connects muscles to bone. The graph shows the variation of force with the extension in this tendon. This is a force extension graph. Remember, extension is in millimeter. Okay, explain whether the tendon obeys Hooke's law or not. Clearly, tendon is not obeying Hooke's law. It is because the graph is not a straight line. That means gradient is not constant. So you can say that tendon does not obey Hooke's law. So you can say this. But if you consider that a small portion, like from here, you can say yes, for a small portion till 0.5 millimeter, it is obeying. After that, it is not obeying. It's up to you. So you can consider and you can ignore this small portion. So you can say the overall graph is not a straight line. So I will prefer saying that it is not obeying Hooke's law, because the overall graph is not a straight line. But if you can divide your answer into two region or two portion, you can say that for a small portion, and you can give some number, it is obeying Hooke's law, but after that it does not obey because graph is not a straight line. It's your choice. Part B, calculate the stress in the tendon at force 4000 Newton. Cross-sectional area of tendon is 101 millimeter square. You need to find a stress, and clearly the stress sigma is force per unit area. A straightforward question, but there's a key point you need to understand. Force is given at 4000 Newton. Area is 101, but it is not meter square. This is millimeter square. So clearly, first you need to convert this area into meter square. And how do you do that? You just replace the value of m, which is milli. So 101 milli is 10 to the power minus 3, but it's just not a milli. This is milli square. So instead of 10 to the power minus 3, you do 10 to the power minus 6 meter square. So this is the area in meter square. So you just substitute the numbers and you say this is 4000 divided by 101 into 10 to the power minus 6 meter square. And if you solve this, your sigma would be equal to 3.96 into 10 to the power 7 Pascal, or you can round it off till 4. That's how you can figure out stress. Calculate the strain in the tendon at force of 4000 Newton. Unstretched length of the tendon is 43 millimeter. So this is the graph, because if you see, you need to find a strain, and a strain is change in extension divided by original length or original size, whatever. So delta x over L, or sometimes you can say delta L over L, same approach. where x is original length and delta x is change in length. So you need to find delta x at 4000. So at 4000 delta x is this. So you can figure out that amount. This is the delta x, and from this diagram this delta x is 2.1, 2 point. So delta x is 2.3 millimeter, and original or unstretched length is 43 millimeter. Because strain is the ratio between two same quantities, so you don't need to convert these millimeter into meter. It's just waste of time. You can do, it's fine. I'm not saying you don't do that, but it's just a waste of time. So instead you just directly use this formula. So epsilon or strain is 2.3 divided by 43. So strain is 0.053, and there must be no unit of a strain because ratio between two same quantities. So this is the strain in tendon. A website states that there is a small risk of damaging this tendon when landing from a jump. The force required to damage this tendon is 10,000 Newton. Use graph to estimate the energy transferred to the tendon when this force is applied. So we are given force extension graph, and of course for force extension graph, if you need to find the energy, that means you need to find area under the graph. Clearly in this graph you have different approaches to find the area because it is not a straight line. So you can count the square under the graph, meaning you will have to this is the region that you need to find the area, and you can count the square under this graph and find the area, the total area. This will give you the energy transfer. Or you can estimate the area by dividing this whole region into a triangle and a trapezium, but it's not a complicated one. There is another technique I will be using here by drawing a horizontal line so that I can divide this graph into two regions. And the idea behind this I will explain. First let me draw the horizontal line, and this is the key idea in this technique. You need to choose a position on the y-axis to draw a horizontal line so that you can have a rectangle. But this is just not a random horizontal line, it should be a suitable position. And after looking at this whole graph, I think this is 400, so 24, 26 and 32. I guess if I draw a horizontal line here like this. Now if you see what I'm doing here, I'm going to find, I needed to find area under the graph, but I am going to find area of this rectangle that I drew here, this rectangle. And what I'm doing in this area, I am including this external area in my calculation, and this external area is going to compensate the area that I should have included. So this area that I excluded can be compensated with this region. So that's what you need to choose the horizontal line. So if this area is approximately same as the area that you are excluding, so area of this rectangle will give you area under the whole graph. And because it's easy to calculate the area of the rectangle, so for me the area of the rectangle A is equal to this is the height, which is I took, I guess 3200 Newton times and the length into breadth, and this is 3.1, 2 and 3, yes, 3.3 millimeter into 10 to the power minus 3. Don't forget, because we are about to calculate the energy in joule, so length or the distance should be in meter, 10 to the power minus 3. And if you calculate the area, A would be equal to 10.56. And this area is basically energy. So energy is equal to 10.56 or 10.6 joule. Calculate the energy that must be transferred when a person lands from a jump of a height. So energy transfer of jumping from some height, mass is given, height is given. It's all about gravitational potential energy. So GPE is mgh. So you can say that 65 times 9.81 times height is 0.5. So GPE is 318.82 joule. Suggest why the risk of damaging this tendon is small. The reason is when the jump is taken, during the jump or after the jump, the energy is also transferred to the other parts of the body and distributed the whole structure, that kind of stuff. That's why the chances of damaging tendon is very small. Question number 17. Submersibles are used to dive below the surface of the ocean. The photograph shows a submersible called Deep Sea Challenger in 2012. The Deep Sea Challenger descended 11 kilometers to one of the Pacific Ocean's deepest point. The material used to make the submersible was strong and tough. State what is meant by strong, what is meant by tough. So strong means it is difficult to break, a large amount of force need to break or bend or whatever, or you can say strong means difficult to indent or scratch. There are many things. And tough is you can say a large amount of energy is absorbed in a material before breaking, and it can be permanently deformed and can absorb a lot of amount of energy. So that's how you can define strong and tough. The submersible had a mass of 11,800 kg. It initially descended at a steady speed. Complete the free body diagram for the submersible while it descended at a steady speed. So it is going under the sea with the steady speed, constant velocity under a fluid. Three forces generally act: weight acting down, and we have upthrust acting, and we have drag force depending on the motion, whether the object is rising or descending. Here the object is going down, that means drag force should be acting upward. So that's the direction of forces, and you need to draw the arrows. So you can say that you have weight acting down, this is weight, and you have upthrust acting, and you have drag acting. So you can say upthrust or drag, whatever you use. That's how you can draw the free body diagram. Make sure that the arrows should touch the object in free body diagram. Part 2, calculate the resistive force on the submersible during this part of the descent. Resistive force means you need to find drag. And in this diagram, clearly it is at a steady speed, so all the forces are balanced. So you can say that U plus D is equal to W. That means D is equal to W minus U. And so you say that W is a weight, which is mg, and U is upthrust, which is equal to rho vg. So you can substitute all the numbers. So D would be equal to, m is the mass of the submersible, which is 11,800. So 11,800 into G, which is 9.81, minus rho is the density of the fluid, in this case density of the seawater, which is 1020. So 1020 times volume of the submersible or the object which is moving through the fluid, and volume of submersible is 11.4. 11.4 times of G, which is 9.81. You simplify this equation or solve this right hand side. So D would be equal to 1.7 thousand Newton. This is the drag force or opposing force or resistive force. Part 3. A mass of steel was released from a submersible in order to make the return trip back to the surface. Calculate the minimum mass of the steel that would need to be released. Assume that volume of the submersible is still 11.4 meter cube. Okay, so you say that suppose you have a submersible at the bottom. In this case, you have a weight acting down and upthrust is acting upward. And if you need to make the return trip, you need to release some additional mass, some extra mass from this submersible, so that upthrust is greater and it can pull the weight in upward direction. So that means you must find the difference between upthrust and the weight, and this difference should be released from the submersible so that it can move upward. So that means W is equal to mg, and this is 11,5758 Newton, and upthrust is rho vg, that we have already done before, but I'm showing here again, and this is 11,4070.68 Newton, and the additional weight which should be released should be difference between these two. So the W dash is equal to W minus U. So W minus U. So if you subtract these, you have 1687.32 Newton. This is the weight that should be released, and if you divide this with the 9.8, so mass would be equal to W dash divided by 9.81, and mass would be equal to 172 approximately kg. So this is the minimum mass that must be released. Part C. The temperature of the ocean decreases as the depth increases. The graph shows the viscosity of the water varies with temperature. Explain the effect of change in temperature. This is a typical question. Change in temperature on the viscosity and the speed of motion of a particle through the fluid. So if temperature is decreasing, viscosity increases, that produce a more force, so speed is decreased. That's how you can link with all the three quantities. So depth increases, temperature decreases, viscosity increased, causing resistive force or drag to increase, so it moves slower. Thank you very much for this video. I hope you enjoyed it. See you in the next one.